Hello, pre-calculus students. This is Mr. McAllen, and I'm just going to give a quick video on the revenue problem that we worked on in class. So, what we started off talking about, all these examples were about quadratic modeling and different types of applications for quadratic modeling. Our first application today, we talked about how we maximize area for a rectangular object, and then we talked about the height equation for a projectile. But the last example we gave was about maximizing revenue. And we started off by talking about how revenue is equal to the price that you charge for something multiplied by the quantity of items sold. So sometimes if we raise the price of something, the quantity we sell will drop. But that doesn't necessarily mean it drops. Sometimes if we're on a revenue curve, if this is our revenue curve, and this is X is the number of items that we sell, sometimes we may be operating below maximum profit, and we just don't know that we're not at that maximum, not profit, but profit revenue. We just don't know that we're below it. So sometimes we'll send people out and we'll have marketing studies done that will suggest that if we raise the price, it will change perhaps the number of items that we sell, but it might increase the amount of revenue that the company brings in. So we have an example here, just a fictitious company. It basically says Binary Books does a marketing survey on pricing. They find that sales average 2,000, I'm sorry, I can't read. I can read, but I'm just having trouble today. 20,000 books per month when the books cost $4 per book. And the marketing survey said that if they raise the price just 50 cents, then the sales will drop by 500 books. And sometimes that may be catastrophic for your company, but remember, this is 20,000 books being sold per month. And by increasing the price just a little bit, you may drop off on sales, but you may or may not see an increase in revenue. So how do we determine that? So let's first write up what the revenue function would be. Revenue is a function of x is equal to two things. The price is a function of x times a quantity as a function of x. So based on the data, the price is right now $4 per book. But if I raise the price by 50 cents per book sold, I might see a change in the quantity sold. And the quantity information from the marketing survey suggested that although you're selling 20,000 books per month, if you do raise it 50 cents a book, you're going to see a loss of 500 books for every increase that you have. So what X represents is X is the number of increases of in sale price. For example, if if I raise the price by 50 cents just once, X will be 1. If I do it twice, X will be 2. So this would be my revenue function. And if you want to FOIL it out, that's fine. You'll have 80,000 plus 10,000 X minus, this will be 2,000, pardon me, X, and the last term will be 250 X squared. When we combine terms, we have 80,000 plus 8,000 X minus 250 X squared. Now, we did talk about, oh, there's something going on with the computer here. Okay, there we go. We did talk about we could find using our quadratic formula the x value for maximum, and that would be, well, not the quadratic formula, but we know the axis symmetry would be the x value would be negative b over 2a. We could look at it on a graph also, and we'll verify that. So if I do this calculation here, I have negative 8,000 over 500. and that would amount to 16 for a value of X. And that 16 is not a price increase of 16 cents. That's 16 increases in price of 50%. I mean, 50 cents. So that would be like an $8 increase in our price on the book. So some people were saying if I raise the price that much, they were saying in class that that's going to jeopardize how many we sell. But in terms of revenue, it's going to maximize or put us at the point for maximum revenue. So if we look at the graph in Desmos, I already have it plotted, and I plotted it in the pre-foiled form, and I'll just turn off the price function and the quantity function. You could see from the graph that that we were operating when our price was only $4. And if you look at that point right there, at 4 comma, revenue was $108,000. We were well below maximum revenue. And maximum revenue is at this point here where we have the price increase is 16 50-cent increments, or $8 more. We would have our revenue to be $144,000. So clearly you could see that where we were operating was not at the, as for lack of a better word, optimal location for price. Anyhow, I hope this video helps you understand this idea much better for the revenue problem, and there will be some example problems in the textbook tonight with the same sort of process but just different scenarios. So hopefully this makes it more understandable, and I look forward to hearing your comments.